Assalamualaikum warahmatullahi wabarakatuh. For today, we discuss about the Taylot series. One of the series that actually you have done this before, maybe in calculus, but I'm confident you have done in the wave enumeration. But maybe you not remember, but it's okay. We can continue in the Taylot series. Part of the important thing in the physics. Okay. So what is the Taylot series? They have some equation related to the series. You can check the textbook if you want to see how we can get this equation. So for this moment, I think just use this equation, and you can check from the textbook. They try to show that the reverse engineering how this you get the equation. So right now, example, we have a function. Okay, we have a function of the fx. Okay, right now fx. Okay, fx equal to something. Okay, so the series become between here is a f for the c is the center point. Example, you have graph. Okay, so they decide at any point here is a c. Okay, and then you need to differentiate the function. First differentiation, second differentiation, third differentiation, fourth differentiation, and actually so on. You will continue because it's a series, infinite series. And then they have factorial below this. If you remember, 1 factorial is equal to 1, 2 factorial is equal to 2 times 1, 3 factorial is equal to 3 times 2 times 1, 4 factorial is equal to 4.3.2.1, or we can put here 4.3 factorial, the same thing. Okay, and this they already told you this is a differentiation, and then C is the center point. Okay, and next, maybe it's quite easier if we check the example. Okay, then you can get more understanding the topic. Okay, so we can go to the example for function fx equal to ln x. The center point is c. Okay, you can check here. The center point is c for function fx for ln x. So for fx, okay, we know that fx is equal to ln x because of this function. Okay, maybe you can check the answer. Okay, ln x, fx equal to ln x. When we differentiate ln x is equal to 1 over x. You can check from the calculus how we can get ln x to 1 over x. Okay, 1 over x, when we differentiate, we can get minus 1 x squared. If you remember, you can check here, 1 over x is equal to x power of minus 1. When we differentiate, we got here minus 1 will be in front, minus x, and then minus 1 will be minus 2. So it's equal to minus 1 over x squared. Okay, so this one, and then next will be 2x third. Okay, differentiate this equation. This is easier. So you can bring in the front, we can become minus plus 2x, minus 2 minus 1 become minus 3. So it's become 2x power of 3, and then the last one will be 6 over x4 minus, so minus 3 times 2. Okay, minus 6x minus 4. Minus 3 minus 1. Okay, so this will be the differentiation of the fx. And the next, because remember the equation, the long equation that I showed you before is fc. So we change everything to c. Okay, and then the question is c equal to 1. So when c equal to 1, ln 1 is equal to 0. Ln 1 equal to 0. 1 over x means 1 over c, means 1 over 1 is 1. Minus 1 over 1 square, minus 1. 2 over 1 power 3 is 1. Minus 6 over, 2. Minus 6 over 1 power 4, minus 6. Okay, so this will be the value for c equal to 1. So we call back equation, okay, that I already showed before, this equation. And we can substitute with the function. Fc is equal to 0 here. Fc, okay, equal to 0. F prime c, okay, equal to 1. C is equal to 1. So this one also equal to minus 1, 2. This one is minus 6. And then we have here c change to 1. So we can write again for fx, okay, the function fx equal to ln x equal to 0, and then we have here plus 1x minus 1 power of 1 over 1 factorial. Okay, 1 factorial is 1, and then we have minus 1 x minus 1 power square over 2 factorial is 2 times 1, plus 2x minus 1 power 3 factorial is 3 times 2 times 1. Okay, and then plus minus 6x minus 1 power 4 over 4 factorial is 4 times 2 times times 3 times 2 times 1. Okay, so here when we want to write the function, can cancel this 0, remove 0. Okay, 1 and 1 is we can cancel. 2 we can remove here, and then 6, 3 times 2 is 6. So we can write again the equation function for ln x is equal to x minus 1, 1 same here, minus x minus 1 square over 2 plus x minus 1 power of 3 over 3, and minus x minus 1 power of 4 over 4, so plus. So now we have the equation, the series for the Taylors, but now we want to get the summation. Okay, summation of the series, it become the Taylor series. You can see that for this, because we want the starting point n equal to 0, so we have n equal to 0, n equal to 1, n equal to 2, n equal to 3. Okay, for n equal to 0, value here 1 and 1. Here is 2 for n equal 1, 3 for n for 2. For n equal 3, we have 4 and 4 value. Okay, oh sorry, 6 actually already cancelled. Okay, so now we have the same parameter here. We have x minus 1, so you can put here x minus 1. We can check that because for n equal to 0, the value is 1. N equal to 1, value is 2. So we know that this is n plus 1. Okay, here n plus 1, power of n plus 1 over the value here also same with the top. So we have here n plus 1. Example, we can check for n equal to 0. Okay, if n equal to 0, we have here x minus 1 power of 1, and over n plus 1, 0 plus 1 is 1. So it's same with this. If n equal to 1, so we have here minus x minus 1 power of 1 plus 1 is 2, and then 1 plus 1 is also 2. So same with here. The only difference now we have the change between plus minus here. To do that, we know that minus 1 power of n. Example, for n power of 0, n equal to 0, n equal to 0, minus 1 is positive, because anything power of 0, the value will be 1. And then n equal to 1, negative 1, n equal to 2 is a positive 1, n equal to 3 will be minus 1. So it's similar to the value here. So we can put here minus 1 power of n. So this is the function for the Taylor series. Okay, for function fx equal to ln x at c equal to 1. Next, you can check for the another example. Look a little bit scary, but actually a simple one. Okay, so because we are using the exponential fx, the function fx is equal to exponential x with c is equal to 3. Okay, so we have here fx equal to exponential x. Now we differentiate exponential x to become, if you remember, okay, so if differentiate fx, the exponential x will become ex exponential, also exponential x, exponential x. If you remember, when we differentiate the exponential, since that the exponential x is maintained, they will differentiate inside. Inside is x, so differentiate become 1, so it's still the same, differentiate against several times. And then we change x to c, c is equal to 3, so the value is for exponential x is exponential 3 here. So everything is exponential 3. And we can replace everything here, exponential 3, exponential 3, exponential 3, exponential 3, exponential 3. Okay, this equation from the Taylor equation, okay, we already substitute C with 3 here, okay, to make it easier for us to calculate. Okay, so this is the series function for the exponential x, okay. So this is the series. You can check the similarity here. We have exponential 3, which is, we can say that is a the exponential 3 is constant here, maintain. This is should be the function x equal to exponential x, not exponential 3. Okay, I can once again I will put here, and okay, the exponential 3. Sorry, x. This is x actually. Okay, exponential x. So the constant will be exponential 3. We have here e3, and then we have x minus 3. X minus 3. Okay, the only thing we need to check is the power of what and the factorial. We can see here for n equal to 0. Okay, no value here. And n equal to 1, n equal to 2, n equal to 3, n equal to 4. So the n value is similar to the numbers as a factorial. So we can check, put here x minus 1 power of n over n factorial. Is it correct? For n power of 0, n equal to 0, so x minus 1 power of 0 is 1. 0 factorial. For 0 factorial is equal to 1. So this is the Taylor series for the exponential. Okay, ex. Sorry, again ex. Okay, so the Taylor series for the function fx equal to ex for c equal to 3. So that's all for Taylor series. Next, we can go for the Maclaurin series, quite similar with the Taylor series. Thank you.